Hello, algebros. We are going to use Cramer's rule to solve this. So I'm going to color that off of there. All right, now I have more room. All right, so I'm going to go ahead and make my denominator matricey, if you will. So that's going to take my coefficients from the x's and the y's. So that's 1, 1, 5, 1. So that's going to be my denominator for both the x and the y. So I'm going to go ahead and solve that one so I don't muddy up the rest of my work. So you crisscross your multiplication. So remember you're here. 1 times 1 is 1 minus that 1 times 5 is 5. So that's going to equal -4. So we're going to divide both the x and the y determinant by -4. So now I'm going to find my x. So I need to replace my x coefficients with the solutions. So I'm going to have a matrix of 3, 1, -1, 1. Where they come from. And that's where they come from. All right, let's find the determinant of that. 3 times 1 is 3, minus 1 times -1 is -1. 3 minus a -1 would be 4. And so I need to divide by this value over here. And so my x value would be -1. Y. So now I need the x coefficients and the solutions. So I have 1, 5, 3, -1. So again, oh, I could just do those the same color. What am I thinking? There we go. So I find the determinant of that, which is 1 times -1, which would be -1 minus 3 times 5, which is 15, equals -1 minus 15 would be -16, and then I need to divide by this number, divide by -4, and I get +4. So since we're solving a system of equations, we don't want to write our answer like this. We want to write our answer as an ordered pair. So our answer would be -1, 4. So remember, in ordered pairs, it's always x and then y. And also disregard those directions. We're not solving by graphing, although it would probably be faster. Well, then you'd have to, well, yeah. You wouldn't have to get into slope-intercept form, but it would be easier. But anyways, there is kind of a segmented Cramer's rule. All right, I am going to do number 3 now. So let me get rid of this problem so I have room to write. All right, let's do a different color. Okay, so I'm again going to find the determinant of those values, and that's the number that I'm going to be dividing by. So just a quick reminder, remember that what we divide by is that every time. So you could find it once and then use it again. So that's what I'm going to do. Thinking smarter, not harder. All right. So you do the crisscross multiplication. 3 times 4 would be 12 minus 2 times 1 is 2, and that would equal 10. So my x and my y, I'm going to have to divide by 10. So let's make our x. And remember, we're going to use our, we're going to replace our x coefficients with these values. So those values are going to go first. So we have 6 over 8 and then 2 over 4. And again, order does matter, so we need those x values first. Okay, to our little crisscross multiplication, 6 times 4 would be 24 minus 2 times 8, which is 16. So then we subtract that, which would be 8. But don't forget, if you're not writing it like this and you're doing it kind of segmented like this, don't forget to divide by this value right here. So divide by 10 and we get 4/5. All right, let's find our y. Okay, so when we create our matrices, we want to replace the y coefficients with the solutions. So we have 3, 6, 1, -8. Why did no one tell me that this was a -8? I knew I didn't have any numbers like this. Come on, guys. That's your job. It's probably Jillian's fault. I knew that didn't seem right. Okay, 24 minus a -16, which would be a +40, and then you divide that by 10 and we get 4. That makes much more sense because I didn't think I had any crazy numbers in here for you. All right. 3 times -8 would be -24 minus 6 times 1, which would be 6, equals -30. And don't forget, we need to divide that value by this 10 over here. Divide by 10 and we get -3. But since it is a system of equations, we don't want to leave our answer like that. We want to write our answer as an ordered pair because that's what it truly is for -3. All right, and there were 2 problems solved using Cramer's rule.